So today you're starting a new section, which is section 12.1, and you have actually seen it a little bit before, but they make it a little bit more complicated. So it's talking about with arithmetic and geometric sequences, and you guys have done that before. And again, don't write any of this down. So arithmetic is, oh wait, how is a pattern growing? Oh, you're adding 10 every time. Geometric is if you're multiplying or dividing by something. Oh, you're multiplying by 3 every time. And then of course there's other types of patterns, like this is 0 squared, 1 squared, 2 squared, 3 squared, but that is neither arithmetic nor geometric. So geometric is when you're adding or subtracting. Geometric is when you're multiplying or dividing, but you always end up multiplying. So even if you were dividing by 2, you would say you're multiplying by 1/2. And then they say, okay, given, a table, right, your explicit, your recursive equation, same thing like this, okay? And so you know that your equations look something like of this form. Let me get another sheet. All right, so here is the explicit y equals mx plus b, recursive. And then here is for the geometric, explicit, and then you guys also had recursive. So what this chapter does is it writes them a little bit differently. A couple of things to know. Of course, this is a linear graph and it could be increasing or decreasing. Exponential graph, it could be increasing or also decreasing. And then you can also have word problems and do the same scenarios. Okay, so that's just a kind of a quick overview of the beginning. So this will be a longer lesson, and yes, copy this down. So take a minute, pause the video, copy all of this information down. And we're actually doing 2 units today. So this is section 12.1, section 12.2. And again, these are the formulas for arithmetic. These are the formulas for geometric. Okay. This is like the rule, like your explicit rule, how you guys used to say it. So that's finding the nth term. And then this is the sum formula. How do you find the sum of, so before, when you guys had done these, they always just say, oh, just write the rule. Now they're saying, well, if I give you a sequence, what is the sum of it? And real quick with vocabulary. So this right here is called a sequence. A series indicates that you would want the sum of the sequence. I kind of use the 2 words interchangeably, so you'll hear me say sequence or series, but there is actually a little bit of a distinction. Okay, so copy all this down, and then I think we'll just go through examples and we'll just go from there. But a sub n, that's a subscript, means the nth term. A sub 1 is going to be the first term. N always stands for the number of terms. Oh, there was 5, there was 10, there was like 20 terms. So N is the number of terms. The D for this one stands for the arithmetic sequence, the common difference, what it's increasing by or decreasing by. So what you're adding every time or what you're subtracting by every time. This one is a geometric sequence and it has a common ratio. Common ratio is what you're multiplying by every time. Also, sometimes referred to as the generator. So common ratio or generator. Copy all that down, and then I'm just going to do the problems from your book. So go ahead and copy this problem down. This is section 12.1, page 759. Find the next 4 terms of the arithmetic sequence. Now you can use the formulas for this, but in most cases you just want to think about it logically. So first figure out how it's increasing, -5 to -2, -2 to 1. So you can see that you're increasing by 3 every time. And you do want to check a couple of terms to make sure that that is correct. So your common difference is 3. If you want to know the next 4 terms, well, that's easy. Just add 3 to that one. And that's it. Now you could have used algebra to figure it out, but this one was easy. So if you're trying to find the common difference, pretty much just subtract one term from the other one. Next problem, page 760. Find the 47th term in the arithmetic sequence And one thing that copy that down, it's really important that you actually identify which type of sequence it is, because you're going to be using different rules for different problems. So in this problem, find the 47th term. Okay, so whenever you want to find the nth term, go back to your formula page. It's this one. So I'm going to just quickly write it down. It's arithmetic sequence. So I'm looking at these formulas. So here's the formula, wrote it down. This is like the 47th term. So this would be like A1, this is A2, A3, A4, A5. So you want the 47th one. So that's the one that you're solving for. First thing you want to do is figure out, how is this pattern growing? Okay, it looks like it's growing by 3 every time. So, and you do want to check a couple of them to make sure that that is correct. So the 3 is the D value. So your common difference is 3. Then we're just going to plug these in. So your first term is -4. N is the number of terms. So you would want the 47th term minus 1 times your common difference of 3. So you would say that the 47th term is, and then again, just simplify it, use a calculator, or you could just write it as A47. So I grabbed my calculator, plugged it all in, exactly the same. So it says that the 47th term is 134. That's it. So this next problem I have is find the first term. If you know that the 19th term is 42 and the pattern is growing by a -2/3. So again, go back to my formula page. I only have this formula, so I'm going to go ahead and write that down. So I wrote the formula down and I want to know the first term. So I'm trying to find this one. That means that everything else cannot be a variable. I have to have a number for everything else. So a sub 1 is my variable. N, what's my nth term? Well, in this case, this is your 19th term. The value of your 19th term, so it's going to be 19 minus 1. Your common difference is -2/3. And this is the value of this one. So a sub 19 is actually equal to 42. So in this case, n is 19, but your 19th term has a value of 42. I'm going to plug this straight into my calculator. So I plugged this into my calculator, 19 minus 1 times -2/3. Again, I didn't do any math in my head, just use a calculator. You could also just work it off in your head. Turns out to be 12. So then you're solving for this first term, add 12 to both sides. So you have the value of your first term is 54. For this next problem, it says write an arithmetic sequence that has 5 arithmetic means between 4.9 and 2.5. So again, this is arithmetic. So you're starting at 4.9. And there are 1, 2, 3, 4, 5 means between them. And then you end up at 2.5. So that's what they want to know. How do you write a formula for that? Is what they want to know. Okay, or actually complete that table. So write this one down and then look at the way your book does it. And I actually solve it differently than the book. So again, I solve this differently than the book. Also look at the way the book solves it because you might like one way or another. So it's arithmetic. So pretty much it's saying, well, I'm adding or subtracting some number to get to this. So some number here, the same number here, the same number here, adding or subtracting the same number. So 4.9 plus 1, 2, 3, 4, 5, 6. 6 common differences is going to equal 2.5. and I'm solving for this. So then you just do your regular math. Divide by 6. Okay, so it looks like my common difference is negative 0.4. And I can check to see if that's, well, they actually only want me to figure that out. So yeah, so let's try it and see if it works. So 4.9 minus the 0.4, 4.5, and complete your table at the same time. Minus the 0.4, 4.1. Okay, 4.1, 3.7, 3.3, 2.9, and let's see if it works. If I did this correctly, then my next answer should be 2.5, and obviously it is. Okay, oh, you can't see. So there you go. Again, I did it a little bit differently, but both methods work. Okay, this next problem, so this is finding the sum of the first 60 terms. Copy that down. This actually has a really, really neat story, and I wish I was with you to kind of explain what it is. So I'm debating to share that with you or not. Okay. So I guess I will share that with you, maybe kind of briefly. So don't write this down. The story goes, and was it Gala? Let's see. So I had to look up his name. So Carl Gauss, long time ago, was kind of a pain in the butt kid. And so he was driving his teacher crazy, and he was young. I think he was like 10 years old. The story changes, but at about 10 years old, his teacher sat him back at the end of the classroom and said, you know what? Go and add the numbers 1 to 100. And he said, okay, so she goes to the back of the room. Not even a minute passed, couple seconds later, he has his hand up in the back of the classroom, and his teacher says, what? And he says, I have the answer. Okay, so this is what he did. He noticed that if you took this series 1 to 100 and you added these, you would get 101. If you added these, you would get 101. If you added these, 101. And of course, that would continue until where? Right, halfways. So when you look at the formula for the sum, it is the first term plus the last term, and then half the number of terms because they meet somewhere in the middle. And so the sum for this one would be, 50 times 101. But you could, use a formula and also have figured it out to be, what would the formula be? It's 100 to first term 1 plus 101. Okay. Anyway, so he kind of thought up of that story. Another side story is, this is kind of neat. Since my husband is into cars and stuff, he was actually looking online for a car, and there was this guy who was raffling a car, and he was selling about 300 tickets. So you could buy a ticket for $1, $2, I think $300, right? So it was kind of a mix, and you would just pick a ticket, and if you got ticket number 5, then you paid $5. If you got ticket number 300, you ended up paying $300. And what you would win is this car. And there was like, a junk car, but so theoretically someone could win that car for $1 or $300. Either way, it was a good, a good bet. But I was curious to say, wait, how much was this guy actually making? And so when I heard about this story, it was kind of neat, and we actually figured out that answer, and you can too now. All right, let's see if it was worth it. Or if you've ever raffled something, maybe you can think about something like that. So we're going to go back to this. I'm going to write down my formula. So I wrote down the formula, and again, it doesn't even matter what the common difference is, this is your formula. So the sum of 60 terms is equal to total number of terms, that was 60, divided by 2. My first term was 9. My last term is 304. So the sum of 60 terms is equal to, plug this into my calculator, and whatever that is. All right, not too bad. Okay, so that's arithmetic. We're going to do the same thing for geometric sequences. Go ahead and copy this down. Now, this says common ratio. As soon as it says common ratio, that's actually telling you that it's a geometric. This has common difference. This one has common ratio. So we're automatically looking at this. Find the next 3 terms. Again, you can use a formula or just think about it. So in this case, you probably already know that to get from 1 to -1/2, you're multiplying by -1/2. So your common ratio is -1/2. Now, if you didn't know that, and this is really important, is that think about it this way. 1 times something will give you -1/2. So 1 times r is going to equal -1/2. If you're solving for r, you would divide -1/2 by 1. So r is equal to -1/2. What that means is that you can always take 2 terms next to each other, and you can divide the second term by the first term to find your common ratio. It would have worked here as well. If I had done 1/4, so say I had done it this way, -1/2 times r equals 1/4. Well, if I'm solving for r, I'm going to multiply by -2/1. Write this down. To find r, and if you have 2 terms next to each other, you can divide the second term by the first term. That's, of course, if you don't see how the pattern's growing. If you see how the pattern's growing, then you don't need to do any of this. So we're just multiplying by -1/2. So times a -1/2 would make it a -1/8 times a -1/2 would make it a positive 1/16, and times a -1/2 would make it a positive. Okay. All right, so those are your next 3 terms. Now this problem, I have no idea. So I'm going to go ahead and use this idea. You can take the second term and divide it by the first term. So to find my r value, it's going to be let's see if this works. So for this problem, I actually have to factor it. So r is equal to 3 r plus 1. Let's see if that works. Okay, can't see. All right, make sure, typo right here. I copied the problem wrong. There is a negative right there. So this makes this a negative right there. So we factor out a -3 r minus 1. Okay. All right, so fix that. So now r is just going to equal -3. Well, let's see if that actually works. So if we have r minus 1 times -3, I get -3r plus 3. -3r plus 3 times -3 is going to be a positive 9r minus 9. Good, so let's go to the next term. So 9 times -3 is -27r and a positive 27. Multiply one more time, so that's going to be 81 positive, negative 81. Multiply one more time, so that's 243 negative, and negative 243r, negative 3 times negative 81 is a positive 243. Okay, nice. Not too bad, right? So this one was nice and simple. This one's a little bit weird, had some more algebra in there. Okay. All right, so this one says, find an approximation for the 23rd term in the sequence. Okay. I know it's not arithmetic. I know it's geometric, so I can rack my brain and try to figure that out, or simply just use my calculator, and it is your second term divided by your first term. So to find your R value, take the second term divided by the first term. I got negative 0.7. Find an approximation for the 23rd term. So the 23rd term is going to be this rule. I'm going to go ahead and write that down. So I wrote the rule down, and I have to find the 23rd term. So this is going to be the value of the 23rd term. So my first term is 256. My common ratio is negative 0.7. You can put this in parentheses if you want, because you have to do the exponent first. N minus 1, so 23 minus 1, so that's 22. Plug this into your calculator. If you're using your cell phone, make sure that you know how to do this. So I already plugged it in and I know the answer. But if you're using your cell phone, you actually have to do exponent base order of operations. So parentheses, exponents, and then your multiplication. Let me get my phone. Right, so final answer is about 0.1. If you're using your cell phone, let's see, make sure you know how to enter it. You're going to do this part first. So it's negative 0.7, but it's to the 22nd power. So I know my answer is going to be positive. So 0.7 to the 22nd power. Hit the equal sign and then multiply times 256. Okay, and then this number should match that. And so it's about 0.1. The 23rd term is super small. Okay, next problem. Okay, so this next question, find the sum of the first 10 terms of the geometric series. Now, you could actually just expand it and write 6 more terms and add up all those numbers, but you might enter it wrong in your calculator, but that works. Now, had they said the first 50 terms, you're definitely not going to write all 50 terms and add them up. You're going to use the formula. So let's just use the formula for this. First thing you have to do is they tell you it's geometric, so you need to find out your common ratio. And I don't like seeing it like this, so I'm actually going to put commas in between. All right, so to find your common ratio, you already know what it is. Multiply by negative 3. Again, if you didn't know that, then you're going to do the second term divided by the first term and get negative 3. Okay. And you can always check just to make sure. Oh, wait, is negative 48 times negative 3? Okay, times negative 3, just to make sure that you did do that correct. Okay, so go back to my formula. It is this one, the sum of a geometric sequence. So I'm going to go ahead and write that down. Okay, take a minute, copy that down as well. The sum of the first 10 terms is equal to your first term, 16, minus, oh, you need to know your nth term, which means you need to know the 10th term. I don't know that, so I have to go back and figure that out using the rule. 1 minus your common ratio is negative 3. Be careful with this one. 1 minus an already negative 3. And, okay, so I'm waiting for this number right here. Your common ratio is negative 3. And to the nth power. And n is number of terms, so that's going to be 10. Okay, so it looks good, except I'm solving for this variable, and I don't know what my last term is. So, again, 2 things. You could work it out and find that 10th term, plug it in, or we're going to use a formula. So, got to go back to my formula. It's this one. I'm going to write it down, and then figure out how to solve for that. So I went back, looked at this, and I found out that I wrote the formula wrong. Oops. So in here, it is a sub 1, not a sub n, which makes a huge difference. So go back to your formula page and change this to a sub 1. So that's the same, that's the same. Going to go back here, change this to a sub 1. Okay, so actually, I need my first term. Do I know my first term? Yeah, it's 16, so I didn't need to know that. If I needed the formula, I would have just plugged it in. But, so this is actually, your first term is 16. Now, this is your equation. You can do the little pieces piece by piece, or you can just plug this straight into your calculator. So plugged it straight into my calculator. If you're doing, it might be a good idea to do all the top and then divide it by the bottom. Otherwise, if you're doing it all in your calculator, be careful with parentheses. And you could always put like an extra set of parentheses here just to kind of make sure. So final answer, the sum of the first 10 terms is negative 200,036,192. Okay, and that is it. All right, good luck on your homework. Again, you have to have this formula sheet just to make sure that you understand that. And hopefully you have that correct. That is your first term, not your nth term. I had that originally wrong. Okay, that's it. Thank you.